Okay, welcome to the Informs Committee on Teaching and Learning session. The session is entitled Future-Proofing Teaching and Research Using Generative AI. And we have a distinguished group of panelists. And I want to begin by, first of all, thanking the Committee on Teaching and Learning for sponsoring this event. We're grateful for that. And also like to thank Graham Warren for organizing the event. Appreciate the opportunity to be here today. And thanks to all of you for attending today's session. We're going to start by, I'm going to ask our panel. I'm Jeff Camm, by the way, from Wake Forest University. So I'm going to be the moderator today. And I'm going to begin by asking our panelists to introduce themselves. And so let's start. We'll go in alphabetical order by last name. So Ram, why don't you go first and just tell us where you are and what you do research in and what you teach.
So thank you, Jeff, for inviting me to be part of this panel, and great to be here. So I'm at Santa Clara University. I am an associate professor in the Department of Information Systems and Analytics. I do have an operations research background, and with a specific, over the several years, in the past, I've worked on problems related to pricing, pricing in marketplaces, as well as other supply chain and related supply chain issues. And of course, in a lot of that, more recently, my research has shifted to the last few years and how actually many of these methods are applied in companies particularly through products. And I've sort of been engaging with the startup ecosystem and others on that front. And that has also infused my teaching in many ways. And so the most recent area of interest for me is, of course, how we apply large language models to solving these problems, while preserving some of the ideas and methodologies we've had before.
Great, thanks, Ram. Erin?
Thank you. I'm Erin Trochim. I'm a research assistant professor at the University of Alaska Fairbanks. I'm a geospatial data scientist. And so my interest in AI and large language models is twofold. So we do a lot of machine learning and deep learning in geospatial work to start off with, but we joke that nobody really uses our data. We're the most underutilized data. So I've been working with large language models since 2020 and been waiting for them to get sophisticated enough, and we're there. So I'm really interested about how we use them to combine different knowledge systems in geospatial, make agents. We're really interested in this idea of Earth agents, and see how we can actually integrate the most common data into the rest of the world.
And how about teaching? What you're teaching? What kind of classes?
Yeah, so I actually teach research.
Okay, so okay, great.
Yeah. So.
Fantastic. Sean?
Oh, hello, everyone. Thank you for coming to our session. My name is Shao. You can call me Sean. I'm an assistant professor in St. Louis University. I do research in pricing and consumer behavior. I use lab experiments and also approximate dynamic programming to study these problems. In terms of teaching, I teach operations management, supply chain management, also pricing at different levels. And I also taught optimization before. Yeah, nice to have you here today. Thanks.
Great. Okay, so we're going to start today's session. I've asked each of the panelists to talk a little bit about how they're using generative AI in research, or how they're researching on generative AI. And so we'll spend some time today on research, about 20 minutes, and then we'll pick up teaching in the second 20 minutes, and then we'll leave plenty of time for Q&A, and I'll be monitoring the chat for the Q&A part. So you should be able to enter questions that you have in the chat at the bottom of your screen, those of you that are joining us. And so let's start. Ram, we'll start with you. If you can share your slides and tell us a little bit, 5-6 minutes about what you're doing in research around AI, that would be great.
Yeah, so I have a common set of slides for both. I haven't separated the slides out from research and teaching. because I
Sure.
actually think that the topics, it can be applied equally. So I'll maybe in the talk track, I'll talk more about sort of how it can be used in teaching versus research versus teaching. So
Sure. Let's see if you can,
yeah, just give me one.
you should be able to share.
So how I think about this topic is if I think about the ORMS world and sort of like the way we think about sort of operations research management science traditionally, and how it interacts with the AI world of today, particularly large language models. I would say there are two ways. One is I think about how to use AI for ORMS, and the other way I think about it is how to use ORMS for AI. So I'll make a distinction between the two, and I'll connect the dots in terms of in terms of research and teaching as I talk through it. So this is just my introduction. I talked about that. So this is my recent book on the AI-centered enterprise. A lot about how to implement AI in organizations and how it's going to change how organizations work. My co-authors here are both strategy folks, so it was kind of a very interesting experience writing this book. Let me talk about the AI for ORMS piece here. I think there are many opportunities for from a research perspective for us to use AI, and there are two distinct phases. I think that the first phase was when deep learning models became really popular. AlexNet, this was 2012, and ChatGPT, of course, was almost a decade later. I think there has been a stronger and stronger shift towards more models that may not be very easily explainable, but actually have a lot of predictive value. I believe that from what I've seen is that those kinds of predictive models have a lot of value in solving real problems for companies. And so from a research perspective, I think the more we can embed those kinds of models in some of the predictive tasks we may have in a research context, particularly if you're being data driven, there is a lot of value in that. So I think that movement actually is not very recent. That's almost a decade old. I think the ability to use these more larger, less explainable, but more high predictive power models. I think that the other change that has happened is, of course, this idea of post ChatGPT. I think there are two major changes. One is this ability to tap into unstructured data in a way that we could not before. So even so looking at it from a research perspective, there was always a tendency, even I had, that if I were to look at something data driven, then I'm looking at primarily only like a data that can be neatly arranged in a table, for example, right, with a nice set of columns. I have changed my view completely on that topic, because I find that often, even in a supply chain context, for instance, there is a lot of data that's not necessarily sort of neatly arranged. It could be a bunch of orders that come through via emails which have details in them. It could be like reports and contracts and so on. Of course, not all of it from a research perspective is easy to obtain, but some of it is. And I think this ability to tap into this, for example, publicly available sources of data, and actually make sense of it using large language models, and sort of embed them in sort of any research question you pose. The same thing I can say is also true for trying to create sort of, and this is maybe a little bit more on the teaching side, but I think I'll talk about a potential research element here as well. Is how do we creating better user experiences. So for example, if you're not just statistical applications, but also, let's say, optimization applications, where you can actually how can you actually sort of create a user experience in applying an optimization model that is very seamless, and that doesn't require a lot of not just no code, but actually like very, very seamless in terms of how the user interacts with solving these problems. And that's, I think, is an important research question as well. The other part of this that I like to talk about is how do you apply sort of some of the ideas we know, like when we talk about optimization, statistical control. A lot of the ideas are in terms of traditional systems. I think we try to build models around it, trying to understand exactly what the objective function is, and how to actually sort of structure a model to reach that objective and correctly. So it's almost like there's a control perspective there. I think that perspective now remains. More large language models are being used in practice for in many application areas. I think a big challenge from a research perspective is actually going to be to try to understand how to how to kind of control the inputs and the design of these architectures so that we can get the kind of outputs we need. So, for example, if you're trying to control some supply chain parameters, how do you actually control? How do you actually create an architecture to control that effectively, as well as sort of measure sort of how well it's performing? And I think that's going to be becoming more and more an important research area as far as I can see.
Thanks, Ram. Can we move on to Erin next?
Perfect, thank you. Let me just switch over to this. Back up to here. Awesome. So nice to see everybody. So echoing on to Ram, our previous speaker, I've been thinking about in the world that I live in between agentic AI, which is more of the individual actors of AI. So and when I'm talking about AI, I'm talking about generative AI, like large language models, versus what's coming, which is AI agents. So, and that's the autonomous system. And so a little bit more about like why I'm thinking about this, and we're going to look at some of my research. So I actually have an EMBA, so I have a business face to what I do a little bit as well. I work with Google Research. I'm a recipient of their Google Research Scholar Program recently. And I'm going to show some of the tools that we've been developing today that are our little building blocks and explain some of the theory about why we're building them. But when we're talking about them, a good way to think about it is that I'm also really interested about how we improve geospatial techniques via deep learning. And there's a lot of relationship between agentic AI and AI agents, and how we use machine learning and how we optimize for deep learning. So I just want to put that out there. And part of the focus of my research is really bridging interdisciplinary and different knowledge bases. And we've been trying to do this for years, just like a lot of operations research. And so this agentic era is essentially designed for us for one of the first times. So one of my projects that's kind of a good example of an AI agent is that we were trying to figure out how to teach students or agents or people in general how to ask better questions. And that seems really simple. You should just be able to do it. You should just be able to search and know what to ask. But that's not quite true. So we went and we thought about how we do it as experts that are actually generalists. And we go through this like series of about 10 steps. And it starts with like asking about the spatial characteristics of a problem, the spatial relationships. And I give you some like example questions here about temporal characteristics and temporal trends. And it turns out that we actually do it twice in geospatial. We ask not only about a phenomenon, so like a thing we're studying, but also about a methodology. And so we developed this framework essentially that we call the geospatial questions framework. And okay, that's great. There's lots of frameworks out there. So what? Well, it turns out you can wrap it in an LLM now, and you can point it at a corpus, and you can see what it does. So we pointed our AI agent using this framework at about 4,800 scientific abstracts that all use a technology called Google Earth Engine. And that means that they're all produced on the cloud. If they're in research, it was available for free. They had lots of capacity, and we were curious about being able to analyze it afterwards. So I built an app because why not? So in research, one of the other big things that you can do now with AI agents is do a ton of vibe coding. And why is that a good thing? It lets you look at things more creatively than we used to before. So we used to set a lot of dashboards and be really rigid in some of our outputs. Now you don't have to do that to the same extent. So this is an app that shows a subset of some of our papers on the side. You can look at the abstracts, and then it goes through what our agent's actually doing. And for some background, we're using Gemini 2.5 Pro, and we've kind of pushed the model to the max of its context window, actually. When we were running it on smaller models, it wasn't working as well. And so that's some useful information. So it's going through and pulling out like initial like plausible starting question, which is pretty helpful. And then we're asking it to pick which of those like primary focuses. Do we think it's a phenomenon paper or methodology paper? Refine what it's doing by using our questions framework, and then essentially kind of critique the paper. And overall, it's doing a pretty good job from an abstract. And this is actually how a human would do it as well. At this point, we would then go read the paper. And so you could see how we could attach another agent onto this. And then what's really fun is that it can go through and start to estimate future research questions just out of using an abstract, just like a human does. And then also estimate what are some of the required data. So we were able to go and do evaluation afterwards, obviously, and we're about to submit this as paper. So yeah, so from an AI, an agentic AI perspective, this is a really good example. I'm going to flip back to my screen. We also did something which was designing a new metadata framework with this exact methodology in mind. Why metadata? Because metadata used to have to be static, and now it doesn't actually have to be static at all. So yeah, so we came up with this new framework called Candid Core, and you can go read about it afterwards and check out our GitHub repo. But this is what we're in the start of using the same approach, agentic AI, to apply this to data sets, to be able to make them more searchable, more findable, and then add on to that idea that if you ask better questions, and you can see in my previous example, that the large language models are capable enough that context actually really matters for them being able to figure out what to do next. So yeah, so anyway, so that's a little bit of my example for research and about where we are and what you can do right now.
Great. Thanks a lot, Erin. We'll move on to Sean and research. You're on mute, Sean. There you go.
Yes. Hello, everyone. I'll talk about my research in consumer behavior, which actually is using AI technology these days. Okay. One stream of my research is on behavior operations management. We actually study consumer behavior either in lab experiments with students as subjects, or collaborating with a large organization like eBay, Alibaba, or Amazon to do some field experiment to learn real consumer behaviors. I would say that during COVID, many researchers actually switch from doing experiment in the lab, in university labs, to an online platform called Amazon Mechanical Turk. And they show that this online platform will have similar behavior performance compared to lab within the university. Since the past 2-3 years, there is a new trend going on. Actually, people are trying to use AI agents to actually replace human subjects to mimic human behaviors. And this new literature is quite interesting. That's why I want to discuss this to you and share some recent progress. Okay, and I would say that in the past 10 years, there has been a fast-growing literature studying human and AI interaction, so in different decision problems. And at the beginning, this literature was called human algorithm interaction. But later on these days, they are called more like human AI interactions. And there is an interesting sub-literature, very new literature, showing that AI could indeed mimic human behavior in many cases across various economics and operations management setting. Here I'm giving you some examples that agents can produce human-like behaviors in many contexts. And I want to highlight the third one. I think most of our audience here are having OR and OM background. We're all familiar with the news vendor problem. So in news vendor problem, we're making decision based on the overage cost and underage cost. So overage cost usually is the buying cost minus the salvage cost, and the underage cost usually is the profit margin. And there is optimal quantity based on this news vendor model. But if we ask the human being to play this news vendor game or make news vendor decision in real life, there is kind of a put to center effect. So instead of making the optimal quantity, the subjects actually is either underproducing or overproducing by making their quantity decision closer to the mean value. And right now, there AI agents can already mimic this well-defined, well-observed put-to-center effect. So this shows that there is a possibility in the future, instead of recruiting like human subjects to understand human behaviors, we can actually use AI agents to mimic human behaviors, so that we can study some problems based on these like AI behaviors to mimic human behaviors. Okay. And there's a group of researchers actually, they built a platform already, and it's called Gliese. So you can actually run different type of decision problems in econ or OM by using their like agents to mimic human behaviors. There are quite of benefits about this AI agents as subjects. First, when we are doing this behavior research, we need to recruit subjects, which are usually human beings. There are huge costs, also time constraints. But right now, with AI agents doing this type of research, it's a lot faster. Okay. And the second benefit is that it opens up new channels for testing theories and mechanisms at scales, because it's very easy to do this type of research these days with AI indeed mimicking human behaviors. And finally, it suggests a possibility of studying how different personality traits and preference can influence decision. Right now, you can actually prime the AI agent with different personalities and make sure that they mimic a human behavior in certain ways. So this is the third benefit. Okay. And there are definitely some challenges and also some drawbacks. The first are the limitations of the AI subjects. The first one is sensitive to prompt designs. And the second one is it lacks of motivation. For example, when we are studying human behaviors in experiments, usually humans making decisions to maximize their utility or payoffs. But for AI agents, it's hard to define a payoff function for them. Actually, we don't know what is the payoff function for them. Okay. In terms of methodology challenges, there are 4 of them. So in human behaviors, we usually assume that human behaviors are independent. Each of us, we're independent human beings. Okay. But in agent-based like experiments, so this kind of independent assumption may not be true, and they're actually trained by the same model, and their behavior could be similarly. Okay. And the second one already discussed is motivation part, is monetary motivation part. And the third one is whether this experiment can be reproduced. So unlike traditional experiment with human subjects, so this AI-based like subject response can vary with updates to their model parameters. So finally, I think it's the most interesting part I want to point out is that, so when we are running this experiment to learn human behaviors using human being as subjects, there is a large variation in terms of behaviors. However, when we're using these AI agents to test behaviors, it usually understates variance. So this large language model, these agents tend to collapse the diversity of judgment into a single model of opinions, making them better at approximating the average instead of capturing the variability. I think this is the key part I will share with you. And in the future directions, I think I also list two future directions. I think there is a meaningful direction to compare this AI agent data with human data and to identify which decision problem indeed we can use AI agent to replace like human data. So finally, I want to say that even though it's quite useful to have this AI agent in behavior or experimental research, but it's more like a complement instead of a replacement. Okay, I think
Great.
that's everything I want to say. And I'm happy to share the slides with you. And these are the papers I discussed in this research session. Thank you.
Thanks, Sean, and keep your slides up because we're going to go to teaching in a minute, and then you're going to be first up on the teaching side. So we heard three great examples, three different viewpoints on how people are using AI for research. And I just remind you, if you have questions, you can put them in the chat, and we're leaving time at the end, and we'll pick up any questions you have. But we're going to transfer now from research to teaching, and we'll go in reverse order. So Sean's going to lead us off on the teaching side. And so I'm going to turn it over to you. But again, for anybody who's in our audience, if you have questions that you would like to, any of the panelists to address, you can use that QA feature. Okay, take it from here, Sean.
Yes, if you have any questions, feel free to stop me. I'll be checking the chat box, and I'm happy to answer your question during my presentation, okay? And I'm a case teacher. I enjoy teaching case. I enjoy building case. I also enjoy using game in my class. I want to share my experience of using Gen AI to glorify my case teaching and case development, and also how can I use this Gen AI to teach students through gamification. Okay, let's talk about the case teaching and case development first. Here, I'm listing the key steps in terms of developing a case. So the first one is funding of the ideas and doing like related literature review. Second one is verify assumption with industry partners, and then collect data accordingly. Sometimes instead of collecting data from industry, you can actually simulate data. It's possible. The third part is writing. It's about creating the case. The fourth one is writing the teaching notes. So sometimes you may write the teaching notes first and then write the case itself. So these two steps, third one, fourth one, so they can go like either way, okay? And then we test the case and then refine the case. Finally, we send the case for case publication and competition, okay? This is a classic six-step case development. So with Gen AI, and many of these steps within this development stage can be speed up. So for example, in the idea sourcing part, I want to share my experience, okay? I'm teaching a pricing class for the past 4 years at SLU, and I have a final project in this class. At the beginning of this teaching, like 4 years ago, I tend to assign some students to do some innovative pricing topics. I allow students to choose their topics, and they tend to choose very large company, and the topic may not be well studied in their final project. So later on, I started selecting topics for them. So I make sure that the innovative pricing topic I assign to them are indeed innovative, and there is a chance of developing those ideas into a case study for future usage, okay? And when I assign this idea to students, actually I also assign them my notes or my diary or my conversation with ChatGPT when I was developing case for my past cases. So in that way, they know how I discuss with ChatGPT, like the different Gen AI platform, and how I do this literature review in large scale. So Gen AI not only help me to speed up this step, and also actually helping students to learn how to use this like a new technology. And the way I share with them my experience also set up a standard for them to achieve. And in the end, most of the students can do a pretty awesome presentation in the final presentation. And for those amazing reports from students, amazing presentation from the students, I'll invite students to work with me further and then develop this their project into a possible case study for future teaching. Okay, and this is how I use GenAI to speed up this idea sourcing and the literature review session. And I also want to highlight that the GenAI can also speed up this testing and refinement part significantly. So before GenAI, I tend to share a case in the final version with my students, ask them to test the case. But right now, with GenAI's help, even with some cases which are not perfect, which are not in the final stage, I'm able to share this I would say 80% finished case with my students as a homework for them to learn. And they can use GenAI to find the potential mistake within the case, to find out potential improvement area in this case, so that it speed up this testing and the refinement stage a lot. Okay, and during this stage, as you can see, I'm also incorporating student as a co-developer instead of a passive learner. And I'm not English is not my first language. GenAI can definitely help me a lot in terms of writing the case and building up this teaching note, and especially help us to make this case more open-ended, especially summarizing these learning objectives from different domain. I think this is the case development part. So do we have any questions so far? Okay, we don't. If you don't, let's move on to the case teaching part. So case teaching part with GenAI is also very easy, very powerful. I consider them into 4 categories. The first one is pre-class preparation. So right now, even if you don't allow students to use GenAI for case analysis, they'll still use it. That's why I just ask them to use it anyway, okay? Before class, I'll ask GenAI to create some concept questions and allow students to use those GenAI tools to answer those concept questions, okay? And during the in-class activity, GenAI actually can create like a movie or a game, which is like a role play type of thing. So to make this within class interaction more like interactive and more engaging. So after this post-class analysis, so this GenAI will allow them to compare their own analysis. So with the GenAI analysis to see where they can improve and where GenAI may make mistake. GenAI tools mistake is quite powerful. So I'll identify some of the mistake from the GenAI argument and teach students why this is not true or in this case setting. And they tend to enjoy more in this kind of discussion. So finally, GenAI can also help us with assessment. So right now, I have a case about cannabis inventory and retail operations management. I'm actually designing I call it a grading AI bot to help me grade this qualitative question initially before I grade those questions by myself. And I plan to share this with all future case adopters so that we can use the future student submission data to fine-tune this AI grading bot further and further, and it will benefit all the future teachers and students. Okay, I think this is the way I use GenAI in terms of teaching cases. Finally, I want to have a summary. I think, in my opinion, these GenAI tools, they're making case development not only shorter, but also wider. For the professors, it will speed up the case creation and definitely speed up the iteration cycle, and expand the reach across like multi-language. It's very easy to convert English cases into like Chinese cases, for example, and increase our teaching creativity by creating those role play within class. And finally, save times on qualitative questions. GenAI can really design qualitative questions in a really good way, so that as a case designers, as a professors, we can really focus on the more complex, more innovative or quantitative question designing. Okay. For the students, they became like a co-creator instead of a passive reader or solver of the case. And they also like to practice AI like decision-making process and skills. And they develop these meta-cognitive skills by evaluating AI outputs. So finally, they can connect different knowledge from different disciplines using GenAI support, well, instead of focusing on a specific domain like operations management. I think that's everything I want to share with you today. Okay.
Yep. Thanks, Sean. And we have a couple of questions in the chat, or one in the chat and two in the Q&A, and I'm going to save those for our Q&A time. And so thanks, Sean. That was great. And Erin, you're up next on teaching.
Erin, I think you're muted.
Yep, you're muted, Erin. Sorry.
Thank you so much. So I'm going to, I appreciate that Sean went first. I'm going to provide more of a practical example. So from the teaching side and teaching research, what's my one piece of advice to my students right now? And what do they get together every week and do without me? They work on agentic AI. And that's because there's so much potential right now. And we need to be exploring it well. So I made a demo to illustrate some of how I've been framing it, a really nice entry point. So we had this research project, and in Alaska, we have communities all over the place, and we were looking to connect it into networks. And that's because we wanted to distribute fuel. So a really classic way to solve that is the traveling salesman problem. It poses a simple question, given a list of points and the distances between those points, what is the shortest possible route that visits each point exactly once and returns to the origin? And so it seems simple. Well, when you put that into reality, of course, you're intersecting with all sorts of other knowledge systems. So we set this up as a combination agent problem. So I've made an example for you that is not in Alaska. It's a toy problem in the United States, looking at some routes. And I've also changed the agents a little bit. And so we'll look through that, and then you'll have the notebook afterwards, and you can play with it and adapt it as you will. And if you have feedback, please contact me. I'd love to hear about it, and I'll probably throw this up as a GitHub repo actually to support conversation better. So the notebook is here, and if I flip out for a second, I'm going to hit this in the chat, so you can also see it in the chat. So let's flip over. So this is a little bit of a complicated notebook. I'm sorry. The backstory is that we're using this package called Crew AI in order to assemble our agents essentially. And so the first part of this is just loading the traveling salesman problem and the route. So we're going to skip over that. Then we set up the Crew AI. Let's keep on going. We're going to go all the way down to the end for a second and just take a look at it. So the gist is that we have different networks essentially. And the traveling salesman problem can be set up from looking at it through like two big different agents. So one of them I've called the passenger experience agent. And so you can set a background story for it, but we're asking it in this example to go and analyze the routes. And so we've got about 8 different routes. They form a closed loop, it knows about that. And so it's going through and it's comparing the distance and then rating passenger comfort, what it would think for that route. And so this is pretty straightforward. It's going to go through and do a lot of things, summarize and justify things and do a bunch of rating. Cool. Well, from a market competition standpoint, that can look very different. And so we can go through and set up another agent to do the same thing. And go through and do the interpretation and geographic overview. And so awesome. So we've got 2 agents going. Well, now what we want to do is actually coordinate between the 2 things. And so to strike a balance between the critical needs of the passengers and strategic market positioning. And so these very much fundamentally build on that traveling salesman problem. So, okay, cool. So we're doing a whole bunch of things. It's going to do a bunch of analysis. Great. What it's doing now is then synthesizing the conflict priorities and trade-offs. We can go through and do it like a complete version of this. We can see where the maps were. And then I've asked it to synthesize some like key insights. And so in this example, this is a really interesting exercise because the traveling salesman problem gives the mathematical optimization, but it ignores the stakeholder perspectives. And the same route segments can be simultaneously optimal and problematic. And what this talks about is that this agent rates long haul trips as being less ideal for passengers, whereas the market analysis rates some of those routes as being incredibly strategic and really important. And so the agent's conflicts reveal the hidden trade-offs in route planning. And the point of this is that real optimization requires balancing competing objectives. And so this is a good example of multi-agent analysis to expose complexity invisible to single metric optimization. So yeah, so hopefully this gets you inspired. You start making some of your own problems like this. But oh man, it is a wonderful time to be a data scientist and work in business and consider it from these like multiple perspectives. Never mind going through and rerunning this. It does give some like very like somewhat different answers a little bit, but actually I'm running it using the Flash 2.5 model, which I've described how to get for free. But yeah, it's interesting how in this example, it's relatively consistent because the models have actually gotten better and the data is pretty clear on this. So that's my quick example. So yeah, feel free to reach out to me.
Thanks, Erin. That's great. And we're going to switch over to Ram. You're muted, Ram.
Sorry.
There you go.
Oh, yeah. So I'm going to go back to the same set of slides, but I'm going to focus on a couple of things here, as well as maybe show you a quick like product demo, which in terms of how I'm thinking about this. So the third bullet point here is the idea of how do you create seamless user experiences, and I think this is something that is particularly important in my teaching, simply because a significant percentage of the people I teach are MBAs, executive MBAs, and people, and so they're not the kind of people who deeply understand sort of like some of these models or are comfortable with using like a command line. So they're very much more comfortable with dealing with sort of a more of a no-code experience. But it's more than just a no-code experience, right? The idea being that how do you in the practical real world, more and more they're going to be dealing with tools of this kind where they have to interact with different kinds of data, including like unstructured data as well as the other data sets, and work with models and so on. So this third point about building seamless user experiences, how do I bring that into the teaching experience itself? Sort of how do you that's something that's I've been thinking a lot about, which then ties into the second point, which is the idea that once you start doing this, even though this we can push this idea of like trying to understand really how these systems work and controlling them from a research perspective. I think even from a user perspective, I think it's useful to understand, both from more effective prompting as well as creating agents as to how you might be able to actually get the outputs you actually need, right? And so that is something that I think is as I've started introducing that. I think till recently I was focusing more on sort of maybe using ChatGPT for exercises. But what I want to show you is sort of as I mentioned earlier. So this I founded this company which basically focuses much more on actual supply chain sort of business users and solving their problems. But I'm increasingly beginning to think that's also a very good way to get students introduced in the classroom to sort of how they can go about solving these problems and learn about solving these problems in a more sandboxed environment. I think one advantage of that is that they get an introduction to how to use these kinds of tools to solve problems. I also like it from a more of a defensive perspective, is that rather than we all worry about students going out to ChatGPT and getting answers. I think if you were to use like a like this environment, then you might actually be able to. I can actually have a trail of exactly. So it does use large language models underneath, but then I have a clear idea about what exactly what information you used and how exactly you went about trying to solve it. So that keeps everything sort of very transparent and so on. So I'll just show you an example of how this works, right? So with a supply chain example, I haven't started using this in teaching yet, but I'm actively thinking about it. And if anyone in the audience has ideas about how they might want to use it in teaching, feel free to reach out to me, and we can sort of make that happen for you, right? So so let me share my screen here. So this is an example. I'm not going to. I'll show you. Just give you a brief description of what this is. This is like a. This is actually a contract between like a transportation carrier and a retailer, right? And which has all kinds of pricing information in it. So I can actually show you what this document looks like. It's actually a pretty complicated carrier agreement. Obviously, all the names and all that has been masked and anonymized and all that, for demo purposes. And so the advantage of this is that it's a fairly complex piece of data, and you need to work with it and try to see if you can get some answers out of it, right? And so if you go to sort of like this chat that I've already set up here, you can actually have an interactive chat. So there are two different contracts that this company is considering. And so the idea then is that, and this is a real problem, but this is also something that can easily be applied in a pedagogical sense. And if you add some, let's say, more data in a CSV file, you can start working with that as well, and so on. So I mean, I think I asked sort of what does this summarize them first. I mean, it told me that these are essentially transportation carrier agreements. And then this is kind of the kinds of questions that people don't answer, right? If I want to minimize shipping costs, what contract should I actually choose? And so the idea here is that it actually gives you like a recommendation, of which contract to choose based on sort of all the details within that. Now there is an entire sort of like a fairly complex prompt engineering layer that go underneath, which actually gets into some of the details, does some planning in terms of how to approach this problem and so on. And the idea being that not only can from a teaching perspective is not only can students work with this and see what the outputs might look like in practice, but also give them the freedom to actually maybe go in the back end and adjust some of the prompts to kind of get better answers, for instance, right? This gives them sort of like a very sort of live experience of what the decision making is going to look like for them in practice as well, sort of. So I think, and that I believe this is going to be integral to to most people's lived experience in business, but also I think it can be a great way to teach as well. So
thanks, Ram. That was great. That document sure did look like a legal document to me, so that was impressive. The contract. So we have time now for questions, and there's some questions in the chat and one in the Q&A. And I think the Q&A one came in first. And Sean, this is directed at you. Can you give a template or show an example of all the steps you're mentioning in that case development? Or do you have one you could speak to, sort of just walk through quickly the steps you went through on your slide and what that meant within the context of a particular case you developed with AI?
Sure. I can share a little bit of like a summary of what I did. So I worked with Porsche US about 2 years ago to develop a pricing case. Actually, the case idea was from a student report in 2022. So at that time, I assigned this topic to them. I know this is an innovative business model, and they did pretty well. And in that final presentation, I record their presentation and share this with Porsche partners. And then Porsche partner became interested in this kind of collaboration proposal. And then we started doing like research about existing cases and about book chapters to match this case with. And then we indeed noticed that there is a niche market for this kind of case. So we started building the case. And in terms of AI's role, I would say that the first version of this case, I wrote it very much like a homework assignment. And the AI indeed helped me make this case more like a story or movie with a wider coverage from different subjects like management, like marketing, some even from accounting, okay, which is not my expertise at all. And when like finalizing this case, I make sure that we use this like a public available cases. There are some public available cases without copyrights. So we can actually ask ChatGPT to summarize the good and bad, especially the strengths of existing good cases, free cases, and then try to position our cases using those good features and modify our final like writings. I think this is kind of my high-level summary. If you need more details, I'm happy to discuss offline. Yeah, thank you.
That's great. Thanks for that. I know I have a colleague here at Wake Forest who used AI to develop a case, and the case has personas, and then he created bots of the people in the case, and the students had to go interview the bots.
Yeah, that's amazing.
And so, yeah, there's a lot of interesting stuff going on with cases. There was an earlier question, just give one, let's give your favorite. The question really was, what type of, when you say Gen AI, what are you using? So tell us your favorite Gen AI for teaching or research. What do you have a favorite?
For me, to build the AI grading bot, I just use ChatGPT.
Okay.
If you subscribe to them, there's a like an advanced version. You can indeed design a like a bot.
Right.
And for research, definitely ChatGPT in terms of doing research review is still not there, and I mainly use it to polish my writing. I would say that.
Okay.
And these days they can do some proof already, which is a little bit scary.
Right.
So I do some backward reduction proving in terms of like dynamic programming.
Yeah, that's great.
ChatGPT can really do that already.
Yeah.
And,
Erin, how about your favorites?
I like to play them off each other.
Right.
Yeah. So in terms of how to, well, you saw a little bit of my research.
Right.
So how do I use it? I tend to use Gemini or Claude. I actually abandoned ChatGPT for a little while until 5 rolled out. So I find it's better now. I do it so that my geospatial questions one that shows batch processing. Batch processing is super helpful, both for being able to like rerun and then evaluate with another LLM agent, or compare many more cases. The context window matters, and yet it doesn't. And so that paper example showed so each one of those papers is one run in the model. And then you could do multi-turn if you wanted to. For the agentic, like the actual multi-agent systems, I've had my students using Crew AI because it was really easy to get onto. But there's some more sophisticated platforms. But that's the one that we found the most approachable, and we tested a few of them. You can also write your own, actually, if it's simple. Not so much the multi-agent systems, but when you just do an AI agent, you just write your own essentially. And what I will tell you is that how you frame it does matter, actually.
Right.
The models have gotten a lot better, especially since about May. So your language and your framing and matching the theory that it might have access to, or you're feeding it, that matters a lot, actually.
Okay.
So, and then
great.
Picking the size model.
Thank you. Ram, you have a favorite or a couple favorites?
Yeah, so it depends on the use case, right? So if I'm doing intellectual sparring and trying to open-ended discovery, I use ChatGPT. I think it's GPT-5 particularly. I think it's the best out there, I think. If I'm talking about coding use cases, I would say Claude is probably much better. Claude, I mean, some people, or combination of Claude and using a cursor type, as a wrapper around it, right? So that's second. If you've not tried, if you want to create mock-up screens, you want to pictorially create mock-up screens using React and so on, I would say Manus is actually very, very good. I highly recommend that. I think that's one area where they are really, really good. And I think in terms of document stuff, document data handling, all of that, our own system, Samvid, actually, which I give you a shout out, we're getting very good at this because we are doing a very good job of handling sort of like the backend data in terms of the documents and the RAG pipelines and so on. So I think it's I end up just dogfooding this. If I'm working with a set of documents, I'm usually going to my system. So yeah, no.
Great. Yep. Thank you. There's one more sort of general question from Paul Clare, actually, and I'll read it to you. It's in the chat, but from a decision scientist perspective, and we just have about a couple minutes left, critical thinking, problem framing, and stakeholder elicitation are critical skills. AI tools can augment analyst skills or become a crutch that undermines critical thinking and creativity. In an educational setting, how do we promote the former while avoiding the latter? So it's just, are we building muscles for our students by using AI, or are we making them less, able to critical think? And final thoughts on Paul's question.
Maybe I can go first. So I tried to show two examples that have very strong theory frameworks. So one of them came from the humans, and it seems obvious, and it kind of is, but it actually hasn't been described super well anywhere, even though we do it. And the second one is a classic algorithm, and hopefully you saw how we went to town deconstructing them, and we're not done yet.
Right.
And so I think it's a pretty amazing time for critical thinking if you set it up this way, and if you promote both the exploration of the classic algorithms and like where do they run out, but also what were we missing? We're missing a lot of critical frameworks that aren't written down anywhere. And I think that this is a great time to inspire our students to create new ones.
Thank you for that. And I think what Sean said before about real subjects and artificial intelligence subjects, that comparison, that kind of keeps you grounded. Ram, you have any final thoughts before we wrap up?
Yeah, on that issue, I think I echo Erin's comments. I think the biggest challenge is, I think you can definitely use it a lot for really great critical thinking and innovation. It's all about how you use it, and I think part of the teaching here has got to be related to how do we encourage use in one direction or another, right? And that itself, I don't think we have cracked that nut completely yet, but I think we now recognize the problem and we're moving in that direction. So I think if you want to be lazy and not use it for critical thinking, you can easily do that, and that's not a good thing. But right. I think we should be nudging people to moving towards the other direction. So
great, I agree. Well, thanks to each of you for being on our panel today. This has been great. And thanks again to the Informs Committee on Teaching and Learning. And I wanted to mention that there, in the Informs meeting in Atlanta, there will be sessions from the Committee on Teaching and Learning. So those of you that have attended today and will go to Atlanta, I encourage you to show up to some of those sessions. And there's also something called TEN, Teaching Excellence and Networking, an event. You can get information about that event that comes from this Committee on Teaching and Learning. That will also be in Atlanta, so you can get information on that on the Informs website. So thanks again to the committee for sponsoring all this. Thanks to our panelists, and hope everyone enjoyed and got some nuggets out of it. I certainly did. I'm ready to roll in both research and teaching in AI. And so thanks everybody, and we appreciate all of you who attended. And there's also going to, before I forget, there's one more thing. There's going to be another one of these seminars more focused on research, I think later in November. So we'll get the word out on that from the committee. So thanks everybody. Thanks panelists, and I hope everybody has a great day.
Thank you, everyone.